This is the tutoring video for Sparky Quiz 4.1 Mars Lander. So I started off by writing all of my knowns in a knowns and unknowns chart. So we know that the initial velocity of the spacecraft is 5,000 meters per second. We know that our distance from the surface is 50,000 meters. The mass of our lander is 36,000 kilograms, and our final velocity is 0 meters per second. Now I have all 5 of our steps written out here. Our first step is going to be using this new equation. The final velocity squared equals the initial velocity squared plus 2ax. So we know that our final velocity is 0. So we have 0 equals, our initial velocity is 5,000 squared plus 2a times 50,000. Now make sure that you have your calculator handy so that you can do all of your calculations. So we'll start off by squaring 5,000. 5,000 squared is this very large number here. You should have 6 zeros afterwards. And I'm just using the numbers that I have on my Sparky quiz, so your Sparky quiz might be a little bit different, but it's still the same process. Then you're adding 2a, yes, you will be adding 2a times 50,000. Now what you're gonna do is you're gonna subtract this number and make it negative on the other side. So you have 25 and then 6 zeros equals 2a times 500 or 50,000. Now what you're gonna do is you're gonna divide this number twice by 2 different numbers. You're gonna divide by the 2 and you're gonna divide by the 50,000. So first we'll divide by the 50,000. We have our negative 25 and then 6 zeros divided by 50,000. You get negative 500 equals 2a. Now you're going to divide both sides by 2 and you'll get a equals 250 meters per second squared. And you switch the negative to a positive because of the fact that your acceleration is moving upwards, as shown by our force diagrams, which you don't need for this Sparky quiz. So we have our acceleration. I'm going to add it to our known and unknown table. And our next step is we're going to be doing time. So our time is our change in velocity over acceleration. So we know our change in velocity is 5,000. Well, technically it's negative 5,000. So we're just going to keep it regular 5,000 though. So we have t equals 5,000 divided by 250. So we're going to put that into our calculator, 5,000 divided by 250, and we get 20. So our time is 20 seconds. That is the answer to the second question on your Sparky quiz. Now, the next question is our net force. So we use the equation F net equals ma. That's an easy one. Our mass is 36,000, so we have F net equals 36,000. And then times 250. So we put that into our calculator, 36,000 times 250, and you get 9 with 6 zeros. 3, 4, 5, 6 zeros newtons. Since this is force, we have our unit of newtons. Don't forget your units, otherwise you will get points marked off. Next, we are doing our force of gravity, so we use Fg equals mg. And we know that the gravity of Mars, I forgot to write this down, but the gravity of Mars is negative 3.7. And then the unit, I'll write that in just a second. So we know we have the number 3.7. So we're gonna use that over here. Fg equals 36,000 times negative 3.7. Now put that in times 3.7, and you can just make it negative. So the answer for the force of gravity is 133,200 negative, and that's newtons. So we have our force of gravity, our F net, our time, our acceleration. Now our last step is to find the amount of force being pushed up in order to slow down and decelerate your rocket. You take this number and you add it to this number. So we take our 9 with 6 zeros, you add the 133,200, 9 with 6 zeros, put that into our calculator, add 133,200, and that is our answer for how much force is needed to decelerate the rocket. Make sure you add all of your units, and that is the walkthrough of the Sparky Quiz 4.1 Mars Lander.